All right, this week's algebra review is going to be on domain. What domain is, when the more math you take, well, any math you take, I'm just about going to talk about domain. So I want you to have a good feel exactly what that is, a good reminder here. Basically, the definition of domain is a set of all possible x values. Your x is, remember, domain is x. It is the x values that will make a function work. And when we talk about domain, we usually talk about the numbers that, or the values that will make it not work. But domain really means a function, the values that will make it work. So I'm going to show you two to do algebraically, and two or three you can do graphically. And your assignment's going to be a delta math, just telling what domain is. Should be quick and easy. Good, hopefully a good review for you. Here we go. Two times to worry about domain. So most of the time, to be honest with you, most functions domain is all real numbers. So you don't have to worry about it. Two times you do have to worry is when there's fractions with an x or a variable in your denominator, or a square root with x inside. Really, I should say even roots right there. If it's an odd root, like a cube root, it's all real numbers all the time. If it's an even root, then you do have to worry about what your domain is or what your value of x can be. The reason with a fraction with x denominator, remember, denominators can never equal 0, so you can never have a denominator equal to 0. Okay, a couple here, and the directions are just tell what the domain is. If it's a fraction, never worry about what the numerator is. I'm only worried about the denominator being 0, so I'm going to factor this one. I'm trying to think of factors of 28 that would give me 3. That would be x minus 7 and x plus 4. So that what that tells me my domain is everything except for 7 or negative 4. 7 makes the denominator 0, negative 4 makes the denominator 0. So two ways you can write this. One is you can write it in what's called set notation. You can do like this, write it like this: all x such that x does not equal 7 and negative 4. You can do it that way, or you can do interval notation, which looks like this: from everything from negative infinity to negative 4, union everything from negative 4 to 7, union everything from 7 to infinity. And I use parentheses because if you use a bracket, you're including the negative 4 and the 7. If you use a parentheses, you're not including the negative 4 and the 7, which I don't want to do because you cannot include negative 4 and 7 in your domain. So either way, you can write it this way, a little shorter, this way, it may make more sense to you depending on how you've done it before. Okay, the second one down here, square root of 2x minus 4. Now this is a little different. Radicals can't be negative. They can be 0 or positive, but they can't be negative. So what you do when you have a radical is you take what's inside the radical and set it greater than or equal to 0. It's always greater than or equal to 0. And then just solve it. Move the 4 over, divide by 2. And because that right there, that's your domain. X is greater than or equal to 2. You can write it two ways. Oops, I don't want everything to move. You can go like we did a second ago, all x such that x is greater than or equal to 2. You can write it just like that. Or you can say it this way: bracket 2 to infinity, which means everything from 2 to forever does work. Notice I put a bracket around the 2 that time because it did equal 2. Okay, the last part today is just looking at graphs and telling what the domain is. I'm looking at this graph, and obviously when I look at that, there's an asymptote that goes right through 3 because the graph is approaching 3 but never touching the 3. So that means when you're looking at the graph, you're looking for domain. You're looking at how far your graph goes left and right. How far is the graph going left and right? Well, this one's going left forever based on that. It's going right forever based on that, but it does skip the 3. So my domain, if you want to write it this way, you could say, well, domain is all x except for 3. Okay, that's your domain. Or if like the other way, you can say from negative infinity, look at the graph. From negative infinity, that's going to negative infinity until it gets to 3. And then it's going from 3 to positive infinity, which is this part, but it does skip the 3. The parentheses means that 3 is not included. So look at a couple more of the graphs. This one, going left forever, comes in and stops at the 6 right there. Remember, domain is x. I just care about the x's, don't care about the y's at all, just domain. So one way I could write that is I could say, okay, all x such that x is less than or equal to 6, because that's your domain. Or you can do this way: look at the graph. The graph's going from negative infinity to 6. 6 with a bracket, because it looks like it does touch the 6. So I'm going to put a bracket there. When you write your domain this way, make sure you're going left to right. That's why I put the negative infinity first, the 6 second, left to right. You got to write it left to right. Let me show you one more. All right, this one's got 2 pieces, and so you got to write the 2 pieces. All right, this one right, this part right here, remember, left to right. It's going from negative infinity until it gets to negative 8. So I'm going to say, okay, the domain is from negative infinity to negative 8. It does touch the negative 8. And then there's a second part, which goes from 1, and it's going right forever. So I'm going to say it's going from 1 to forever. And that's how I'd write that. Now, if you want to go the other way, you'd have to write a couple of things, a little bit tougher to write the other way. But you could do this. You could say all x such that x is less than or equal to -8 or greater than or equal to 1. All right, so either way you want to do that is fine. You can have about 7 or 8 of these on your Delta. You got a Delta math assignment today, and I think about half of it's algebraic, like the first slide we did, and half of it's graph. So just exactly what we did. So get your Delta math turned in, and have a great weekend. See ya.